Okay, good morning. So, I will solve there are 3 examples left from the previous session, so let us go through them and then we go immediately to the new lesson. And by the way, I also published another quiz for number theory, so yeah, please try to do them gradually as before. So, if I remember it correctly, so that was one of the problems. I don't write every details there, but let me just write here. So I ask you, I have given you a function. So this was the function we had. And then I ask you how many points with natural coordinates are there on this graph. Yes? So we, of course, you know that this is the graph of a function. It's a curve and it passes through infinitely many points. And if you look at those points, some points, usually most of the points doesn't have the natural coordinates. But we want to find how many of the points on that curve has this property that they have both coordinates to be a natural number. Yes? So how do you solve this problem? Have you thought about it? So my point is that I want to force x and y be natural numbers. So how can we do that? Any ideas? I want to find x and y in a way that they satisfy this equation, and of course I want to have them natural numbers. Yes? One of them is very easy to guess, yes? Can you guess one of them? Actually, 2 of them are very easy to guess, by the way. Of course not, yeah. So for example, if I put x equal to 1, what happens? The numerator becomes 3, the denominator becomes 3, and then 3 by 3 is 1. So definitely 1 and 1 is one of the points on this graph whose coordinates are natural numbers. For example, 0, of course, the way that I am using n, I am not including 0, but if 0 is acceptable in the natural number, 0 is also another one. Yes? But if this is based on guess, and then the point is that are these the only ones, or we can have more? So this is not a systematic way of answering this question. We need to be sure that we can find all of them. Do you have any idea what to do? Yes, Martin?
Polynomial division work.
Yes, but we haven't studied that. But how should we, if we haven't studied division, polynomial division, what else we can do? Yes, so we can do this. Instead of x squared plus 2, I can write x squared minus 4. Yes, and then of course to compensate for that, I need add 6 to it. Yes, and then you will see y, and then x plus 2. The point is that I can factorize this using the conjugate pattern, and then divide by x plus 2. But so you know that if I have a plus b divided by c, I can write it as a over c plus b over c, yes? Usually we have this and we combine them writing this, but of course this is equality, so you can go the other way around as well. So I can write it as x minus 2, x plus 2 divided by x plus 2, then plus 6, x plus 2. And then x plus 2 and x plus 2 cancel out, and then what I get is this. Let me write it again. Y is equal to x minus 2 plus 6 over x plus 2. Yes? But now, if I move everything to the other side, this means that y minus x plus 2 should be 6 over x plus 2. Yes? I want to have x and y in n, so this definitely is an integer. Yes? If x and y are numbers in the set of natural numbers, depending which one is bigger, which one is smaller, this one is definitely an integer. Even if this is negative, that's okay. Yes? So on the left-hand side, we have an integer. On the right-hand side, we have a fraction. If I have a fraction on the right and an integer on the left, they cannot be equal unless the right-hand side is also an integer. Yes? So this means that this would then imply that if x and y are in n, then this would imply that 6 over x plus 2 should also in n. Yes, we want, this is our demand. So far, there is nothing related to number theory at all. So what I have done some algebra, and I hope that you agree with me. This is another way of writing this equation in a different way. Yes? But from now on, my demand is to have x and y in n. If x and y are in n, definitely this combination is in z. Yes? Yes or no? Okay, and then the left-hand side is an integer, so this then implies that, oh sorry, this should be in z, not in n. This should be in z. Because x and y belongs to n, so let me write the details. Okay, so x and y belongs to n, definitely this means that y minus x plus 2 belongs to z, and then if I give this a name to this equation, then this, using this equation, I can conclude that 6 over x plus 2 should belong to z. Yes? Okay, and then what does it mean? It means that 6 should be divisible by x plus 2. Yes? Otherwise, this cannot happen. So it means that x plus 2 should be a number so that 6 is divisible by x plus 2. On the other hand, x is an integer, is a natural number. So what are the choices for this? This is plus or minus 1, or plus or minus 2, or plus or minus 3, or plus or minus 6, yes? These are the only options. If I do not have these numbers, if I want to have this an integer, this should be divisible by this, so x plus 2 should be one of these 1, 2, 3, 4, 8 alternatives. Yes? Is that clear? Yes or no? Okay. And then I am looking for x. Then I need to do them one by one. So x plus 2 is 1. This would then imply that x is equal to minus 1. X plus 2 is minus 1. This would then imply that x is minus 3. X plus 2 is plus 2. This would then imply that x is 0. X plus 2 is minus 2. This would then imply that x is minus 4. X plus 2 is 3. This gives me x equals to 1. X plus 2 is minus 3. This will give me x is equal to minus 5. And finally, I have x plus 2 equals to 6. It gives me x equals to 4. And x plus 2 is equals to minus 6. It gives me x equals to minus 8. Yes? So these are the numbers. Be careful here. If I wanted to check everything one by one, I have infinitely many alternatives, which is not possible. But now I have reduced infinitely many choices to only 8 choices. Yes? And I can check them one by one. So is the logic clear? So if I wanted to solve this problem just by guessing, I have infinitely many potential numbers. Yes, I have to check all of them. But this way of thinking tells you that don't worry, you don't need to look everywhere. You need to look only among these numbers. Yes, is that clear? So I have reduced the infinitely many possibilities to just a few number of cases. But of course, because in this problem I am demanding that I want x and y belong to n, so even if they work, I don't accept them, yes? So I don't need them, so both of them are negative, forget about them. If 0 is not a natural number, so I can forget about them as well. But here, I forget about this one, but I need to check this, if it works or not. I don't need that one, because that's a negative one. I also need to check this one. So something is clear. If you want to have numbers, natural numbers, starting from 1, you have only 2 candidates to check. Yes? Is that clear?
Yes.
So, but the logic is important. It's not clear yet that these are answers, but these are only potential answers. If there is an answer for this, I don't need to look everywhere. I need to look only in these 8 numbers. And then I check them. If I take x equals to 1 and put it here, what do I get for y? I get 1 again. So that is an acceptable choice, yes? So if I put x equal to 1, then this gives me that this is 1 to power 2 plus 2 divided by 1 plus 2, which is 1. So yes, 1 and 1 is acceptable. And then if I choose x equals to 4, another candidate, let us see if it works or not. Y becomes 4 to power 2 plus 2 divided by 4 plus 2. Yes? But 4 to power 2 plus 2 is 18, and this is 6. And that's also working, yes? But it was not guaranteed. This I want you to understand. There is no guarantee that you cannot stop the solution there. You have to check this one as well. Because this tells you that if there is a pair, that pair should be among these numbers, yes? And then you don't know unless you check them manually to see that if it works or not. So these are the only points on that graph with both x and y coordinates and natural number. Yes? Is that clear? For example, if I change the question to integers, then actually I have 8 pairs to check. Yes? If I change this one to integers, for example, then I have to check everything. For example, minus 1. Minus 1 will also work, yes, because if I put minus 1 here, this becomes 3, and then this becomes 1. So it becomes minus 1 and 3. Yes, that's acceptable. If I put minus 3, then this becomes 9 plus 2 is 11. Minus 3 plus 2 is minus 1, so it's minus 11. So minus 3 also works, yes? I don't know, might be all of them work, but sometimes, so let us, for example, check minus 8. If I put minus 8 here, it becomes 64 plus 2, 66. Yes, it also works because 66 divided by 6, divided by minus 6, it becomes minus 11. So minus 8 and minus 11 also works, yes, if I am asking you to find integers. Yes. Is that clear? Yes.
Can you show again how you chose 1, 2, 3, and 6 to be the possible results?
Yeah, because I want to have a fraction. It means that when I want to have a fraction so that the result of the fraction is an integer.
Yeah.
This cannot happen unless 6 is divisible by the denominator.
But if x is positive 6, then the denominator will be 8.
Yes, but 6 over 8 is not an integer.
So how is that impossible?
No, what I'm saying is that, let me just repeat. My demand is to choose a denominator so that when I divide 6 by that question mark, it becomes a whole number. Yes? A hel tal. So what are the choices for a question mark? You need to think about those numbers so that 6 is divisible by those numbers. The only numbers are plus or minus 6, plus or minus 2, etc. Yes? Questions? No? Okay, so let me just go to the next problem. I don't remember what was, okay, I have it here. The next problem was this. You have A and N natural numbers, and then you know two pieces of information. You know that A divides 5n plus 3, and you know that A divides 9n plus 4. So I don't remember how did I phrase it for you, but we want to see what can I say about A. Or I don't know, how did I phrase that? Can you check it? How did I phrase this last time? You don't have it. Okay, no problems, but this was more or less the problem. I have A and N in natural numbers. I know A divides this combination, also this combination, but I want to see, can I find A or not? Or what can I say about A if this is going to happen? Yes? So do you remember the strategy in these kinds of problems is this? So when I say that A divides, for example, 9, you can immediately say something about A. Okay, you can say that 9 should be divisible by A. So there are no many options for A. A should be plus or minus 1, plus or minus 3, or at most plus or minus 9. So these are the only numbers, yes? But of course, if I have this the other way around, then you have infinitely many choices. Because if I want A to be divisible by 9, A should be a multiple of 9. So 9 multiplied by any number, any integer will work. And how many of them are there? There are infinitely many. Yes? So usually if you have a fixed number on the right-hand side and a variable on the left-hand side, that is much better in number theory. This tells you that the number of options that you have for A is quite limited. Yes? And that's good. So, but here, unfortunately, I had another variable on the right-hand side. So it means that using the lessons that you have learned so far, is this any way for you to get rid of this n by combining these two pieces of information? For example, having A still on the left, but do some of those valid ways of simplifications so that I can get rid of this n on the right-hand side. So then I want to have a fixed number on the right-hand side. If I have a fixed number on the right-hand side and a variable A on the left-hand side, then I can conclude something about A. But how can I get rid of that n on the right-hand side? One of the things that I want you to remember, I told you, if this is a very, very important theorem. It's simple but very effective. If I have A dividing B and A simultaneously dividing C, do you remember I told you that you can multiply this by any number that you like? Of course, integer number. Yes? And then you can multiply this by any other integer that you like and you can add them. Yes? So for example, if I choose m equals to 1, n equals to 1, then it means that from here I can conclude that A divides B plus C. If I choose m equals to 1, n equals to minus 1, I can conclude that, yes? So that's a very simple but very effective theorem when it comes to divisibility. Yes? Is that understandable? So here, by using this idea, I want to get rid of this n. And that becomes simple, yes? Because you are telling me that A divides 5n plus 3, and you are telling me that A divides 9n plus 4. Yes? So, first of all, I want you to understand this step. A divides so I will multiply this by 9, 5n. You will understand why. And then I will write this. First of all, I want you to see, do you understand this? Forget about how I wrote this combination. It is not hard. You will immediately learn that. But do you understand that what I have written here is exactly according to what I told you up there? So what I have written, this is playing the role of your B. This is playing the role of your C. A divides B and A divides C, yes? And then here, this one is playing the role of M, and this one is playing the role of N in that formula. Is that clear? So what I have done, I know A divides B, I know A divides C, and I have chosen myself M to be 9, N to be minus 5. And the reason is clear. Why I have chosen this pair? Because when I multiply 9 in, it becomes 45n. When I multiply this in, it becomes minus 45n. And I told you that my goal is to get rid of n. Is that clear? Okay, so what happens now? This means I multiply this in, 45n plus 27, and then I have minus 45n minus 20. And then you see that I reached the goal. So this is cancelled. So then it means that A divides 7. And then there are not that many options for A. I want 7 to be divisible by A. So what are the only choices for A? Plus or minus 1 or plus or minus 7. So these are the only choices for A. But I have demanded for natural ends, so I just throw them away. The negative ones, I throw them away. So these are the only options. Either A is 1, so let me write A belongs to N according to the problem. So this means that I have only two cases to consider. Either positive 1 or positive 7. Yes? So these are the only possibilities for A. But do you think they are really possible or not? Of course A equals to 1 is really possible. Yes? Because if A is 1, both of them are guaranteed for any n. Yes? 1 divides any number. So definitely A equals to 1 is guaranteed to be one of the cases. But do you think that 7 is still one of the possibilities? Is it possible to really have A equals to 7 for some cases? This we need to be able to guess. Yes? So you see that this is not telling you that A equals to 1. This is telling you that if A is going to satisfy these two conditions, either A should be 1 or 7, but there is no guarantee yet that 1 and 7 are the answers. Is that clear? Okay, but we have to check. Can A really be equal to 1? The answer is yes. For example, let me choose n equals to 1. Then this becomes 8, this becomes 13. And 1 divides 8, 1 divides 13. So really 1 is acceptable, at least for some choices, yes? So here, A becomes equals to 7. Do you think that 7 is also acceptable for some value, at least n? Can you guess that n? So that this will work. Yes, 5 for example, yes. If I put 5 here, 5 times 5 is 25 plus 3, 28. 28 is really divisible by 7. And if I put the same 5 here, 9 times 5 is 45 plus 4 is 49, and 49 is really, so both of them are acceptable, so I don't need to be worried. For example, what I'm saying, for example, let us think that this is the case. For example, assume that instead of having this, you had this condition, and for some reason you get A equals to 4 as one of your options. So you need to throw 4 away, because there is no way that 4 divides that. Why? Because 2n plus 1 is odd. Odd cannot be divisible by 4. So sometimes you get some extra roots, some extra answers that you have to check them if they are really acceptable or not. In this case, yes, both of them were accepted. Okay, if you have forgotten this formula, I want you to remember this. This is a very, very important formula for number theory. But if you have forgotten that, still probably you can solve that, yes, by invoking the definition. So how we do that? then of course you translate everything into the language of equality, and because you have a lot more experience in equality relation than this divisibility relation, might be you can really understand what's going on. So for example, you tell me that A divides 5n plus 3, so what can I conclude? I can conclude that there exists a Q in Z such that 5n plus 3 is equal to A times Q. Yes? And then you tell me that A divides 9n plus 4, so this implies that there exists a Q prime in this time. There is no guarantee that these Q's are the same. So that 9a, the right-hand side, is equal to the left-hand side multiplied by that Q prime. And then immediately it becomes clear, if I want to get rid of n, what to do. Yes, I will do the same thing. I will multiply this by 9, for example. So this becomes 45. N plus 27 is equal to 9a cubed. And I multiply this, for example, by negative 5. So it becomes minus 45, because I know my goal. My goal is to get rid of n. So you see that those are the same numbers that I used there. So it becomes minus 20, and this becomes minus 5a times q prime. And then when I add them, this one and that one are cancelled. 27 plus minus 20 becomes 7. Is equal. When I want to add them, I factor a out. Then it becomes what? 9q minus 5q prime. So definitely this number is an integer. Why? Because q and q prime are integers, so this combination is definitely an integer. So 7 is a multiplied by an integer. So what does it mean? It means that a divides 7. So that is exactly what I got easier. Yes. So even if you don't know that relation, you still can solve the problem starting from scratch. Questions? Okay, there was one problem left. Let us just do that again. But I want you to warm up, so I will write it on the board and wait for you to do it, okay? So that was this relation. So I know that n divides x minus a, and I know that n divides y minus b. I have asked you to show that n divides xy minus ab. Yes? So I want to wait a little bit for you so that you can refresh your memory a little bit. So that was the last example from the previous session. After that, we immediately go to the new lesson. Yeah, 5 minutes is enough, I think. Okay, any progress? Yes? Yes, do you want to say something? Yes?
I mean, it's just to apply the formula and it solves itself.
Definition, you mean?
Yeah, the definition.
So let me just write, and then if I need help, I will ask you. So n divides x minus a, then what happens? This implies that there exists a q in Z such that the right-hand side x minus a is equal to n times q. It's very important to write the other one. You have to write it with q prime. Be careful. Y minus b. Then I can conclude that there exists a q prime in Z so that the right-hand side is equal to n times q prime. Okay. Then what?
I mean, I used the definition with M and B, the one that...
Okay.
Because then you can skip a few steps.
Yes, okay. So which one? So let me start from n divides x minus a, and then n divides y minus b. So then what?
Then we can conclude that n divides. And then for m and n, I chose y and a.
Okay, so yes.
You multiply y by the first one. And then you multiply a by the second one. And yeah, add. And then when you multiply everything inside, you will
it's
get...
finished, yes.
Yeah, it's finished.
So that is more effective, of course. This is the best way. But this depends if you remember that fact. So I told you that's a very important fact. You see how it can be simplified. You see? So n divides x minus a and n divides y minus b. So I want you to understand this is valid argument. Yes, do you remember I told you that if a divides b and the same number a divides c, you can conclude that a divides m times b plus n times c. Yes? For any integer that you want to choose. But of course, in this part you have to be creative. So now Kevin actually was creative to fine-tune these numbers in a way so that if you simplify this, automatically you will get that. Why is that? Because let me just simplify this expression. Y times x is xy, y times a is minus ya, and a times y, and a times minus b. Yes, and then you see that he has chosen these numbers wisely so that this extra piece that he doesn't need will cancel out. And then what is left? xy minus ab. Yes? Is that understandable? This method, I would say this is the best way to do this problem. But this is not probably the only way. If you have forgotten that and you have used to use the definition, you still can do that. So for example, let us just do it, ignore. This is the best solution, I would say. But if we don't do that, we can go back here and still can solve the problem. So in that case, how should I solve the problem? Assume that you didn't notice that you can use this or you have forgotten that. Then usually you shouldn't forget this because this is the main lesson. And then in principle, you should be also able to solve that problem. So what I have to do if I want to continue using this method? So you see, I have a combination of x times y and a times b. One natural step is to multiply these side by side. Yes? But the point is that I will get ab with the wrong sign. If I multiply this by that, I will get x times y. I will get x times minus b, of course. I will get minus a times y. But I will get minus a times minus b, which is positive ab. I would call it the wrong sign. Because if you look at this one, you want to have a combination of xy minus ab, not plus ab. Yes? So to get rid of that situation, this will motivate me to move a and b to the right first. Yes? And I would move b to the right and then multiply them. Let us see what happens now. If I multiply them side by side, it becomes x. Let me write them. Yes? And then if I start multiplying them, it becomes n squared q prime, nqb, anq prime. But then I will have plus AB, but this plus AB is on the right hand side. If I move it to the left, it becomes negative AB as I demand, yes? So if I move this AB to the left, it becomes XY minus AB. And if you see between this one and that one and that one, I can factor an n out. So then what is left for me is nqq prime plus qb plus AQ prime. Yes, do you agree? And then what happens, is this number is an integer or not? Q and Q prime are integers, and N, A, and B are natural numbers, so that's an integer. So N times an integer is equal to this, so it means N divides that. So that's the last step. So I can conclude that N divides XY minus AB. That's also one way to do that. Yes? Okay, but I still say that this is the best. You see that if you use these theorems effectively, you can solve the problems much easier. But it doesn't necessarily mean that you have forgotten about these. You cannot solve the problem. But of course, a little bit more length. Okay, good. Now let us go to the very main topic of the lesson. That's called the division algorithm. Of course, if you write this rigorously, it seems a little bit complicated, but the idea of the division algorithm is very simple. So far, we have talked about divisibility. So far, we have talked about divisibility. It means that, for example, we say 6 is divisible by 2. When I divide them, I get the quotient equals to 3. I don't know, have you heard about the remainder or something like that? If I say that, what is the remainder of the division of 6 by 3? What's the remainder? Yes, so you divide 6 by 3. What is the coefficient? So what is the quotient? It's 2. But how much will remain?
0.
Nothing. So the remainder here is 0. Okay, but sometimes, usually most of the time, the remainder is not 0. And that is the topic, that is the content of the division algorithm, yes? For example, if I ask you, if I divide 25 by 4, okay, so what would be the quotient? At most, how many 4s you can fit into 25? No, more, 6. Yes, but it's not complete yet because 1 is left. And then we say that 1 is the remainder of the division of 25 by 4.
Yes.
Yes, and Q is the quotient. So that's the idea. Okay. But if I want to write it formally, it becomes a little bit more complicated because division algorithm is also related to the integers, so some of these numbers could be negative. Then it might be a little bit confusing, so let me just write this formally for you. And that's called a theorem. The proof we will skip, that's beyond the scope of this lesson. Theorem, the division algorithm. Okay, so I would write let A and B be integers. Let me emphasize that B shouldn't be 0 and B not equal to 0. Let A and B not equal to 0 be integers. Yes? Then you don't need to write then. There exists, or there exist, integers, unique integers. This is also important. Unique integers Q and R, quotient, remainder, yes? Q and R such that A is equal to B times Q plus R. The important part is and R is greater than or equal to 0, less than absolute value of B. Okay, so let me also emphasize this on the word integers. That's also very important. That is also very important. Okay, so that is the content of the division algorithm if you want to write it rigorously. To understand at least what is the content, it's not hard to understand that from a geometrical point of view. So for example, I give you a rod or something, and I tell you that the length of this rod is A. Okay? And then I give you another rod, for example, this one, I don't know. I give you the length of the rod is b. It's important that you really have a rod because the length shouldn't be equal to 0. Of course, here in this algorithm, if a is 0, you don't have any problems, but b shouldn't be 0. Okay, and then I ask you, try to fit as many as these rods that is possible into this bigger one. So you take this one and you put it here, and then you take it, put it here, and then you put it here. Okay, you do it some integer number of times, and then it becomes if you are lucky or not. What is here? If it is smaller than this one, you have to stop somewhere, because if I want to continue with that, I have to put it here. So here I would say that this number is A, this number is B. How many of these B's I could fit here? In this picture, roughly 3. Yes? So I multiply B by 3. Yes, let me write 3 on the right for the time being. And then, but it is not complete. If I want to use another one, I will exceed this. So I have to stop before that. What is left for me is the remainder. Yes? And that one, so let me call it R. So this length is R. But this R is clear, is somewhere greater than or equal to 0. If I am very lucky, it would be completely, so if I am lucky, if it was a little bit longer, so that I can fit exactly one more, nothing will remain, so R can be 0. But it cannot be greater than what? B. Yes? Why? Because what is left here should be smaller than B. If it is bigger than B, I will continue this. I will not stop there. Is that understandable? So you see, I take this one, so let me write the numbers here so you are not confused. From here to here is A. From here to here is B. In this picture, I take one of them, so that is 1B. And then I will take it another one, it's 2B. And I take it another one, it's 3B. But you see that I cannot put the fourth one here. Yes? Why I cannot put the fourth one here? Because what is left for me is less than B itself. Yes? Otherwise, I can continue this process. And you see that geometrically, it is very, very clear that this is always the case. You can imagine this process can go forever until it can continue until, not forever, it can continue until that you have something left. But if this part which is left is not less than B, I will not stop at that point. I will continue. Yes? I continue until that what is left is exactly 0 or less than that length. Yes? So that is, this part geometrically is very clear. The reason that you have absolute value here, because I have emphasized that A and B are integers, so I haven't excluded the negative values from here. But the negative values cannot be viewed geometrically, because in geometry the length would be a positive number. But at least for natural numbers, you can immediately realize that this is not something very strange. Yes, that's what you expect. Okay, but this is very important. So this word means that if you respect this condition, you will not find more than 1Q and 1R. Yes? If you respect this condition. For example, if I write 25 playing the role of A and 4 playing the role of B, this can be Q and this can be R. Okay? Do you think this R that I have written here satisfies this condition? Let us check. R is greater than or equal to 0, which is true. R is less than absolute value of B. Absolute value of B is 4 and R is really smaller than 4. So if you want to respect this, every one of you will find this pair of numbers, nothing else. But if you do not respect that, I can write like this. I can write 25 equals to, instead of, I write 4, but instead of 6, let me write 7. And instead of that, I can write minus 3. Yes? Of course, this is also, I can give the role of A to this. This is B. I can say that this is Q, and I can say this is R. Of course, A is still equal to BQ plus R, but this R that I have written here does not satisfy this condition. Yes? If you want to force yourself to satisfy this condition and this condition simultaneously, every one of you will find the same value for Q, the same value for R. It is not possible to be able to find more than one pair. Yes? Yes? In that case, this is why something is unique deserves a name in mathematics. I can call this the, not a, the quotient. And I can call this the remainder. Yes? The quotient of the division of A by B, the remainder of the division of A by B. So this article is coming from this fact that you can prove that this is unique. These are unique if you want to respect the second condition as well. Yes? Is that clear? Okay, so the content is hopefully clear, but I know that this might be a little bit counterintuitive, so especially when negative numbers are involved. So let me give you a simple but a very important exercise so that you can understand what is going on. I have already written the numbers here. Oh, okay, here. So, example. In each case, determine the quotient quotient and remainder of the division A by B. Now, by the way, let me write these names. This is also good to know. When you write A plus B is equal to BQ plus R, and if R is greater than or equal to 0 and is smaller than absolute value, this I told you it's called the quotient. This is called the remainder. This one is called the dividend. And this one is called the divisor. Okay, so it's good to know these names, especially the quotient and the remainder you have to know. So A is called the dividend and B is called the divisor. It's a little bit bad name, divisor, here, because when you say 2 divides 6, 2 is also called the divisor of 6. But that's what it is, so you need to learn. If you have this division algorithm, the divisor is also this number. Okay, now let me write the numbers. I want to wait for you, okay? Part 1, A is equal to 23, B is equal to 5. So you can start doing that yourself. So be careful, I am always asking you about the division of A by B. Yes? We want to find the quotient and the remainder for these divisions. A is always the left-hand side. A is the dividend, B is the divisor. Even in this case that A is smaller than B. So I want to wait a little bit for you so that we can continue after 5 minutes. Okay, so let us start solving them. Yes, this is a simple problem. So A 23, B 5. So what can I write? For the part 1, I can write 23 is equal to 5 multiply. What is playing the role of Q here? It's simple. It's 4 plus 3. And you need to write this. And 3 is greater than or equal to 0 and less than absolute value of B. Okay? Because this is true, then I can say that the quotient is 4 and the remainder is 3. This is of course, you really didn't need to know this algorithm to be able to find Q and R. Okay, but let us go to number 2. So number 2, I have chosen A to be 28 and I have chosen B to be minus 6. So what can I write? So 28 is equal to minus 6. Okay, this is A, this is B. So what do you write for Q and what do you write for R? Minus 4 plus 4. Yes, let us check if this... First of all, is it correct from numerical point of view? Yes. Minus 6 times minus 4 is 24, plus 4 is 28. So this equality is valid. But before calling this Q and this R, I have to check that this is correct or not. So, R greater than or equal to 0, yes, that's okay. But it should be less than absolute value of B, absolute value of minus 6. Is this also true or not? Yes. So that, yes, you are right. So Q is minus 4 in this case. R is 4. Yes, thank you. But be careful. You need to check this one. Number 3. I have both. So I have this one negative, this one positive. So let us see what happens. So what is your choice? So I have to write minus 31 on the left. I have to write B. Okay, what do you want to choose for Q? What is the Q here in this case? Minus 5. Yes, I think you are right. Minus 5 and then I have to write plus 4. Yes? First of all, is it correct? Yes. 7 times minus 5 is minus 35 plus 4 is minus 31. So it works. But I have to check this one as well. 4 is greater than or equal to 0. Definitely is correct. An absolute value of 7. Yes? Yes. So that's correct. So Q is negative 5. This is probably the most counterintuitive one, because minus, you might think that I have only 4 of them in minus 31, but according to algorithm you have to choose one more and then come back again because you want to keep it positive. So be careful. So might be I put a star here, so if you want to review, this is probably the only. So here I have chosen both of them negative. I don't think that's a problem here. So let us just do that. Number 4. A is minus 25, B is minus 3. So what should I choose for the quotient? 9 is correct, yes. I have to write 9, so it becomes minus 27, but I have to add 2 to go back. And then, again, 2 is greater than or equal to 0 as less than absolute value of minus 3. So this means that Q is 9, R is 2. So here you see Q, the quotient can also be sometimes negative. But R cannot be negative. R has to be non-negative. Okay, so let us go to number 5. Number 5 is minus 15 equals to minus 3. What should I multiply here? Minus 5.
Yes.
No, it's positive 5.
Yes.
Yes, positive 5 and plus
0.
plus 0. Okay, so what does it mean? So 0 is also greater than or equal to 0 and is less than absolute value of minus 3. So that's also a fact. So here the quotient is 5, the remainder is 0. And what is the last one? Be careful, I haven't asked you to divide B by A, I am still asking you to divide A by B. Okay? Because in the division algorithm, I just told you that B shouldn't be equal to 0, but I didn't tell which one is bigger, so it means that it doesn't matter. And that's important to know. So what do you think about 6? A, which is 5, should be written on the left, and then 17. What will play the role of Q? I have to multiply it by some Q and plus some remainder. Q should be 0, yes? So Q should be 0 and plus 5. Is this 5 acceptable? Yes. It's greater than or equal to 0. It is a smaller than absolute value of 17. So Q here is 0. And the remainder is the smaller number itself. Yes? So the quotient can also be 0. And the remainder is the smaller number in this case. So you see that hopefully you understand. If you want to find the quotient and the remainder, what is important is first of all what you write as equality is a true equality. But secondly, this should be also fulfilled. When you have both of them, you can call the Q the quotient and R the remainder. Okay, but let me give you some more interesting examples. Okay, so let me clean this. So example. The remainder of the division of an integer number A by 12 is equal to 10. Determine the remainder of A by 6. So these kinds of problems you need to improve your skills about, okay? Of course, this problem is simple, but very important to understand what's the meaning of the quotient and the remainder. But these type of problems you need to learn how to solve. So I have a number, A. When I divide it by 12, the remainder is 10. This time I want to take the same number, but instead of dividing it by 12, I want to divide it by 6. And I'm asking you what would be the remainder. Yes? So that's the question. Okay, let me solve this first problem for you myself. So the remainder of the division of A by 12 is equal to 10. So what does it mean? It means that you can write A equals to 12 multiplied by a quotient, which I don't know, but I know the remainder. What is the remainder? It's 10. Yes? So more or less when I read the first sentence, if I want to phrase it in mathematical symbol, I can say this. And of course, if you want to be clear, Q is some integer, which we don't know. It's not given in the problem. Yes, is that clear? So I divide A by 12. I get some quotient, which I do not have any information regarding that, so I just wrote Q. But I know that the remainder is 10. By the way, is this an acceptable remainder? Yes, because 10 is smaller than 12. But now I want to ask this question. If instead of dividing A by 12, if I divide it by 6, what would be the remainder? The same A that I know its remainder by 12 is 10. I take the same A, this time I divide it by 6, and I'm asking what will be the remainder. For example, first of all, when you want to divide A by 6, A is good to have it on the left, but instead of 12 you want to have 6, yes? Because you want to divide by 6. So what you can imagine is to write 6. Instead of Q, I can write 2Q. This is the same Q. It becomes 12 plus 10. Now, can I tell you that, okay, I can give this a name, capital Q. Of course, Q is an integer. 2Q is also an integer. And then I say that A is equal to 6 capital Q plus 10. And I say that, okay, now it seems that I have divided A by 6 and I got 10 as the remainder. Do you accept that 10 is also the remainder for this new case?
Yes, yes.
No. Be careful. For 12, 10 was good because 10 was smaller than 12. Yes? But here 10 cannot be remainder by 6 because 10 is greater than 6. So even though what I have written is correct, but my conclusion that 10 is the remainder is not correct. But how can I fix it then? How can I fix it? I would say that A is equal to 12. So I want to have some, okay. So let me write it in this way. So I would write 6 times 2Q. Instead of 10, I write 6 plus 4. Yes? But why is that? You will say, this is very simple, by the way. I can factor 6 out. Then it becomes 2Q plus 1 plus 4. Is this an integer? Yes, because Q is an integer, so this combination is an integer, so I can call it a capital Q. It belongs to Z. Let me write it. This belongs to Z. So let me give it a name. So then it becomes A equals to 6, some number, and then plus 4. But now 4 is greater than or equal to 0 and smaller than absolute value of 6. So now this is exactly right combination for division by 6. So the remainder is what? Is 4. Yes? So if I have a number, for example, 70, consider 70. If I divide 70 by 12, how many times? It becomes 5 times and then plus 10. If you divide 70 by 12, the remainder is really 10. But now let us divide 70 by 6. So how many 6s I can fit into 70? 10, 11, yes? And then 6 times 11 is 66. How much is left? 4. So the remainder is 4. But that is not a coincidence. For any number of that property, if you divide this. If someone asks you, do you know the quotient here? I would say no, because I don't know A. But what I know that the new quotient is 2 times the previous quotient plus 1. And then, for example, here, you see this was the quotient in this case. The quotient in this case is 2 times this plus 1. But we don't know because we don't know A. What we can be sure about is the remainder, and the remainder is 4. So is that kind of argument clear for you? Yes? So you should be able to train yourself for these kinds of arguments. So let me just give you one more example and then end the lesson today. So, and then we continue. Of course, this lesson will continue next session as well. Okay, so let me write another one. I want to wait a little bit for you. Now you have a little bit of experience. So, example. the remainders of the divisions of integers a and b by 19 are 3 and 17 respectively. Determine the remainder of the division, you don't need to write the division, the remainder of 2a minus b by 17. I want to wait a little bit for you for this one, because if you can solve this problem on your own, so it means that you actually understood everything regarding division algorithm, but there could be some harder problems we can just go for the next session. So let me read it again. The remainders of the divisions of the integers a and b by 19 are 3 and 17 respectively. Determine the remainder of 2a minus b by 19. I wrote 17, 17 was wrong, 19. Okay, so let us solve this one. So the remainder of the divisions of integers a and b by 19 are 3 and 17 respectively. So what does it mean? It means that if I take a and divide it by 19, I will get a quotient which we don't know anything about, so let me write q. But I know the remainder is supposed to be 3. What I know is that, of course, q is an integer. And we also know that if I divide b by 19, I don't know what the quotient is. I'm not allowed to use the same letter, so I just use q prime, for example. But the remainder is 17. But what I know is just q prime belongs to z. That's what I know. But then I want to have this combination. So it is natural, yes? I need to multiply this by 2. I need to multiply it by negative 1 and add them together. Yes, if I multiply this by 2, it becomes 2a. It becomes 38q plus 6. And if I multiply the lower one by negative 1, it becomes negative b is minus negative 19q prime minus 17. And if I add them side by side, 2a minus b is exactly what I want. And then I will have 38q. Let me write minus 19q prime next to it. And then I have 6 minus 17, which is minus 11. Of course, I can factor a 19 out because still my goal is to find the remainder of this by 19. So I should have a factor of 19. But the point is that minus 11 is not acceptable for me as the remainder. So I need to adjust it. And that is not hard, yes? Can you tell me what should I do? So I will copy and paste the first two terms. Okay, I do not want to have minus 11. I want to have a number, because if I am interested in division by 19, the remainder should be somewhere between 0 and 19. So what can I do? How should I adjust minus 11? So how should I do that? Instead of minus 11, I write minus 19 plus 8. First of all, do you agree that minus 18 plus 8 is minus 11? And why is good? Because I want to have a factor of 19. Now this is a factor of 19, a factor of 19, a factor of 19, so I can pull it out. So this becomes 19 times 2q minus q prime minus 1 plus 8. Yes? And then this one is an integer. Q and q prime are integer, 1 and 2 are integers, so you can see that everything is an integer, so this combination is an integer. I can call it capital Q, for example. it becomes 19 capital Q plus 8. But do you think 8 is an acceptable remainder in division by 19? Yes, because 8 is greater than or equal to 0 and it is less than 19. Absolute value of 19. So this means that the remainder that I am looking for is 8. Okay, so here I could factor a 19 out. I could factor a 19 out, it becomes 2q minus q prime. I still can call this q, but even though this is true, but this is useless, because then I cannot call this the remainder. So I have to adjust it by simple thinking. How can I make it positive and smaller than absolute value of 19? So the answer to this question is A. So these two examples are very important, and you see that they are simple. So you need to know what is the importance of this last part. Okay, thank you. No questions? Okay, thank you very much.